In this video, we'll be talking about miscellaneous properties of vectors that I did not cover in the first few videos because I felt that they were really not related to the topic or simply because I missed them. So the first thing we'll talk about is parallelism. So parallelism, if you have two vectors, what does it mean if they're parallel, right? That means they point in the same direction. So for example, you have A like that, let's say going from O to A, and let's say you have another vector going from B to C, right? Going from B to C, and this vector is BC. So let's say this is OA and BC. What does it mean that if they're parallel? So OA is parallel to BC if and only if, right? If and only if means that it goes both ways. So the logic goes both ways. I'll elaborate on that later. If OA equals to lambda BC for some lambda that is the real number minus away the 0, meaning that for some basically i.e. non-zero lambda. So what this means is that if there exists a real number, a non-zero real number lambda that will scale BC to give you OA, then the two vectors are parallel. And likewise, it goes the other way, that if the two vectors are parallel, then you can find some real number lambda that will scale BC to give you OA. So the if and only if simply describes that in terms of logic, right, if you can find some lambda that satisfies that scales BC to give you OA, then the two vectors are parallel. And if you can find, and then the other direction would be if the two vectors are parallel, then you can find some lambda that satisfies OA equals to lambda BC. Okay, so that's what it means by if and only if. Okay, so so with that, let's see why that is true. I think if you have listened to the scaling video on the first video on this lecture series, is pretty obvious, because if the two vectors are parallel, then what if you line them up side by side, right? If you bring OA, you draw OA here, then you can see that the vector OA like that is simply if you scale it up, then it'll equal to BC. And likewise, if the vector, so then that begs the question also, are we saying that these two vectors are parallel? And in fact, by this definition, yes, we consider these two vectors parallel because we can find a negative number, right, which is also a real number that's non-zero, that so a negative number falls into the range, it falls into a set of non-zero real numbers. So yes, we consider these two vectors parallel, even though by definition, even though you might consider them anti-parallel in some cases, in some terminology. But so that's for parallel vectors, right? Parallel vectors would be useful when we talk about lines. And okay, the next thing to talk about is the ratio theorem. So what is the ratio theorem? It tells you how to find, this often comes up in questions where they tell you to find a point between 2 points. So let's say I have a point A, right? So there's a vector OA, and there's a point B where there's vector OB. So what if I want to find a point P that is on the line AB? So on the line AB, and let's say they say P is a point on line AB, that the ratio between AP is to PB is lambda is to mu. Then the ratio theorem tells us that OP is equals to lambda OB plus mu OA divided by lambda plus mu. So the way to remember it is that you have lambda OB plus mu OA. They kind of go opposite sides, and this is intuitive because if you think about what happens if lambda is equals to 1 and mu is 0, then if lambda equals to 1 and mu equals to 0, then OP is just equals to OB, and that would make sense. So yeah, this switching kind of thing, it makes sense if you consider the extreme cases where lambda equals to 1 or mu equals to 1 and the other one is 0. So that's the ratio theorem. And so for the midpoint, right, if let's say if we had a case of so for midpoint, in the case of midpoint, if lambda equals to mu, right, then if they are equal ratio 1 to 1, then that will mean that OM, right, M is the midpoint between A and B, is equals to OA plus OB divided by 2. So that's easy enough. Okay, so yeah, so actually with that we are ready to move on to we're ready to move on to there's some miscellaneous stuff that I want to mention first. So before we move on to lines, right, the next lesson we'll move on to lines, but before that I just want to mention that sometimes you see in questions they write something like I hat plus 2j hat plus 3k hat. So what does this mean? This means that this is the vector 1, 2, 3. And how you understand that is I hat is the vector 1, 0, 0, right? J hat is the vector 0, 1, 0, and k hat is the vector 0, 0, 1. So these are just unit vectors in the x, right, for I, y for the j, and z for the k hat. So these are unit vectors in the x, y, and z directions, as you can see here, and they're unit because their length is 1. So that's another thing. You'll see often questions they write it this way because they want to save, they don't want to save space from writing the column. It's easier to type for them. Another thing is sometimes you will also see questions write it as like that. So sometimes you'll say the point A has the coordinates 1, 2, and 3. I think you've seen this before, right? That means the x, y, and z like that. Yeah. And another thing is that the cross product, so the dot product is commutative. So I should have probably mentioned this in those lectures, but the dot product is commutative, and the reason is because if you work it out, right, a b c dot d e f is equals to ad plus be plus cf, and that is also equals to def dot abc. So the cross product is the dot product is commutative, but the cross product is anti-commutative, meaning that a cross b is equals to minus b cross a. And there's two ways to see it. So to see this, one's a geometrical picture, right? If your right hand rule, if you flip your middle finger and your second finger around, right, then your thumb has pointed in the opposite direction. So that's one way to see it. Then the numerical way is to look at a number, right? So instead of having, if you have a b c cross d e f, then instead of having instead of having b f minus c e, right, and the other two I won't write, but instead of having that, right, if you have d e f cross a b c, then you have instead e c minus b f, which is negative of the above. So yeah, so that's the way you can see it numerically. Yeah, and one more thing to mention is that the cross product is that the cross product and the dot product is distributive. It's like how it behaves with scaling. So if you have k a, right, dot b then that equals to k a dot b. Likewise for the b, right? And for the cross product, if you have k a cross b, then that equals to ka bracket cross b. Yeah. If you take the magnitude of both sides, so magnitude of k a cross b equals to is the magnitude of k times the magnitude of a cross b. So yeah, those are just some rules for the cross product. Okay, so yeah, okay, so if not, I'll see you in the next video where we can discuss lines.